Today we're going to look at factoring out common factors. So when there's a common factor, you want to check for both a numerical common factor and a variable common factor. Remember that the shortcut for a variable common factor is that it's the lowest exponent. So if we take a look at this first one where we've got a cubed and an x cubed is really x, and x is just x. So when we're looking for a common factor, we want to look at how many they have in common. So in this case, it would just be an x to the first power. So the reason that the common factor is the lowest exponent is because that's the maximum amount that they would have in common. Okay. The other thing when we're taking out a common factor is generally it's conventional to take out a negative if the first term is negative. So if we look at 4 and 20, we want to see if there's a number that goes into 4 that also goes into 20. So 1 goes into 4 and 20, 2 goes into 4 and 20, and 4 also goes to 4 and 20. So we're looking for the greatest common factor. So in this case, our greatest common factor is the 4 and the x, and then because our first term is negative, we're going to take out that negative. So when you're factoring out, factoring is the same thing as dividing. You're just doing with variables and multiple terms. Okay? So if we take out the negative 4x, this is what we're really thinking when we're taking out the negative 4x. We're really doing negative 4x cubed divided by negative 4x and negative 20x divided by negative 4x. So then here I can calculate what this is by doing negative 4 divided by negative 4, which is 1. And then x cubed divided by x squared. Remember, when you're dividing with exponents that you subtract. So 3 minus the unsaid 1 is 2. So this will be x to the second. Now I don't have to write that 1. I can, but I don't have to. So then here we're going to do negative 20 divided by negative 4, which is a positive 5. And then x divided by x is a 1. So 5 times 1 is really 5. Okay? So that 1 doesn't impact what's happening to it. So then our final answer is really negative 4x times x squared plus 5. Now you can always double check by distributing. So negative 4x times x squared is really negative 4x cubed. And negative 4x times 5 is really negative 20x. So you can check your greatest common factor once you've taken it out. Okay? So we can look at this one here. We've got a 4, an x, and a 12, and an x squared. So again, between x squared, which is really xx, and x, the common factor is just the x. Okay? Between 4 and 12, we have a common factor of 4. You have a common factor of 2, so let's just momentarily pretend that you thought the greatest common factor was 2. So if we take out a 2x, then we're going to do 4x divided by 2x. And then we're going to do 12x squared divided by 2x. So that 2x stays out in front, and then 4 divided by 2 leaves us with a 2. X divided by x is an unsaid 1, or you can think that it's really x to the 0, but anything to the 0 power is 1, so then 2 times 1 is just 2. Plus 12 divided by 2, which is 6. X squared divided by x is x. Okay? So then when we look here, we've got 2x times 2 plus 6x. So if I check what's left over, notice I still have a common factor. So that means you got a common factor. You didn't get the greatest common factor. Well, you can easily fix that. So if I look for my greatest common factor here, there's a common 2. So I would take out another 2. So we keep the 2x that's already out there. I'm going to multiply it by another 2, and then I'm going to do 2 divided by 2 is an unsaid 1, or not unsaid, it's an actual 1 because there's nothing left. So 6x divided by 2 gives us 3x. So then we multiply out in front the 2x times 2, which gives us 4x times 1 plus 3x. Okay? So if you miss a common factor, you can catch it at the end. Now notice if we were to distribute here, we would still get this answer, but it's not the greatest common factor, so I would not get full points for it because I'm still missing that 2 that's in common that needs to be pulled out. Okay. Now you can have more than 2 terms. So if we take a look at this one, we've got 3 terms. So we still do the same thing. I'm still looking between all of these. So if we look at 16, 28, and 28, So if I think of my factors of 16, I've got 1, 2, 4, 8, and 16. So I'm going to check those numbers against 28. So 2 goes into 28, 4 goes into 28, 8 does not go into 28, and then 16 does not go into 28. So then we have a common factor of 4. So 4 goes into all of these. Now if I look between r squared r and no r, there is no r in this one, so there cannot be a common factor of r. So our greatest common factor here is just the 4. So when we take out the 4, we're going to do really 16r squared divided by 4, negative 28r divided by 4, and negative 28 divided by 4. So then we can carry out each of these individual dividings. So then this is 16 divided by 4 is 4, and then you keep the r squared. 28 divided by 4 is 7, and there was a negative, so I just keep that 7. That r stays with it, and 28 divided by 4 is still 7. It was still negative. Okay. So I double check my parentheses that are left over between 4, 7, and 7. I only have a common factor of 1. If I pull out the 1, nothing's going to change. 4 times 1 keeps it at 4, and then if I divide all of these by 1, it keeps it exactly the same. So this is my final answer with our greatest common factor taken out. Okay. If we try another one with 3, if we look at this one, we've got 4, 40, 40, r squared, and r cubed, and an r. So first of all, we've got an r that's in each one of these. So an r is part of my greatest common factor. Between 4, 40, and 40, I have a common factor of 4. Because my first term is negative, it's conventional to take the negative out with it. So I'm going to do my common factor as a negative 4r. Now, we've been looking at how this is really negative 4r, and then I would take each term and divide by the common factor. So 40r squared divided by negative 4r, and negative 40r cubed divided by negative 4r. Okay. So what I'm going to do here is once you get used to dividing these, you don't need to write them. If you're at that point already, then that's great. If you're not, then use this as a step to help you get to the answer. But you can also just think negative 4r divided by negative 4r leaves us with a 1. So we took out the negative 4r, and I have a 1 left over in my parentheses. Then negative 40r positive 40r squared divided by negative 4r is a negative 10r. And then negative 40r cubed divided by a negative, negative 40r cubed divided by a negative 4r gives us a positive 10r squared. Okay. So then this, if I double check what's left over, between 1, 10, 10, I only have a common factor of 1. Between no r, and r squared, it's just a 1 still. So if I take out the 1 here and divide all of these by 1 here, multiplying by 1 here doesn't change the value. Dividing by 1 here doesn't change the value. So I know I've got the greatest common factor taken out all the way. If you opted to not put the negative out in front as part of your common factor, then you would just have the opposite sign on everything. So this would be positive, this one would be switched to negative, that would be positive, this would switch from positive to negative. Okay, so both of those are correct, but it's conventional to take the negative out when you have the negative in the first term. Okay. So this one has more than 3 terms, but our process is still exactly the same. You're still checking between all of your terms. So if I look at 24, 9, 24, and 27. So generally I start with my lowest number. So in this case, that would be 9. And then I look at my factors of 9. So 9 has 1, 3, and 9. So then I'm going to look at 1, 3, and 9 with your 24 and 27. So 3 goes into 24, 3, that's 24 still, and 3 goes into 27. So 3 goes into all of those. 9 does not go into 24, but it does go into 27. So it has to be a common factor with all 4 terms. So because 3 goes into each one of these, that means that my common factor is going to be 3. Now I look at my variables. I have an n to the 9th, an n to the 3rd, an n, and no n. So because this one does not have an n, I cannot have an n as part of my common factor. So then, because our first term's negative, we've got our greatest common factor is -3 and then no n, so just a -3. So now instead of writing this divided by this, I'm just going to mentally think it in my mind. So -24 divided by -3 is a +8. And then I would take my n to the 9th divided by any n value here, which there is not one, so it just keeps it as is. So n to the 9th. And then 9n cubed divided by -3 is a -3n cubed. And then 24n divided by a -3 is a -8n. And then 27 divided by a -3 is a -9. Okay. Then I can check between 8, 3, 8, and 9. 8 has, well, 3 is my smallest, so 1 and 3. Well, 3 doesn't go into 8, so there's no common factor other than 1. If I pull out the 1, if I times this by 1, it stays the same. If I divide all of these by 1, it stays the same. So that's my greatest common factor. That's been factored out entirely. Okay. So more terms isn't harder, it just takes slightly longer because there's just more of them. Okay. Now, this one may look intimidating because you've got multiple variables, but the way that we do it is exactly the same. So I'm checking my numbers between 21 and 3. I've got a common factor of 3. That goes into both 21 and to 3. Since my first one is negative, I'm going to take out the negative. Now, if I look at my variables, I've got a y cubed and a y. So I take the lowest exponent, which is y to the first. I check my next variable, which is x cubed. I have an x cubed here, but I have no x's here. So x's cannot be part of my common factor. Okay? So if there's more than one variable, it just means that you have to check for a common factor in each variable. Okay? So then here, this will be -3y. So I'm going to do -21 divided by -3. I like to do number divided by number and then my variables divided by each one. So -21 divided by -3 is a +7. Y cubed divided by y. Remember, when you're dividing with exponents, you subtract. So that gives us y squared. And then this x cubed divided by no other x cubes leave me with just x cubed. So then I take my next term and I'm going to do -3y divided by a -3y, which leaves me with -3 divided by 3. -3 is a +1. Y divided by y is you subtract the exponents, so that's y to the 0. Anything to the 0 power is really 1, so this is really times by a 1, which doesn't change the value. So you can just do this part in your head if you can manage that, and just get that this is -3y times 7y squared x cubed plus 1. I do, however, have to have that 1 right here. I can't just write the 7y squared x cubed and not the 1. Notice if we were to distribute back through, this -3y times the 1 gets me this -3y. Okay. Let's try one more. So here, if we look between 12 and 8, 8's my smaller number, so 8 has 1, 2, 4, and 8. So I'm going to look at 8 does not go into 12, so I check my next one. So 4. 4 goes into 8 and 4 goes into 12. So 4 is going to be my common factor. I check my variables between x to the 4th and x to the 5th. My lowest exponent is the 4th, so x to the 4th. Then I check my y's. Y cubed and y, my lowest exponent is a y to the 1st. So now I'm going to do 4x to the 4th y. I don't need that 1 power with the y. You can put it if you want. And then I'm just going to think in my mind this divided by this. So 12 divided by 4 gives me 3. X to the 4th divided by x to the 4th is 1, but 3 times 1 is just really 3, so I'm just going to leave that as is. Y cubed divided by y gives me y squared because I'm doing the 3 minus 1, which gives me 2. Now I'm going to do -8 divided by 4, which is -2. X to the 5th divided by x to the 4th is x to the 1st, because I'm doing the 5 minus 4, which leaves me with 1. Y to the 1st divided by y to the 1st leaves me with y to the 0, which is the same thing as 1. If I times 1 by this, it leaves it the same, so I'm just going to end up with this. Okay? So again, it's not harder. It looks intimidating because there's multiple variables and that can be nerve-wracking, but you just take them one by one. So check your X variable, check your Y variable, check your Z variable, your W, your R, your X, whatever variable it is, you're just checking individually on each one. And then when you've pulled it out, you're just dividing each one, and then that gives you your greatest common factor factored out.